This lesson is on the Poisson distribution. Just like the binomial distribution and the geometric distribution, the Poisson distribution also is a special discrete distribution. So for discrete distribution, we know that there are two important properties. First of all, the random variable x takes exact values only. For example, small x takes values 0, 1, 2, 3, 4, etc. And the second property is that the sum of all probabilities add up to 1. So these two properties will also apply to the Poisson distribution. And the Poisson distribution is named after Siméon Denis Poisson, who was a French mathematician, and his work was published in 1837. Now, for x to be a Poisson variable, that is, for x to be modeled by a Poisson distribution, x must represent the number of occurrences of an event in a given interval of time or space. That is, it represents how many times an event is occurring in a particular time interval or space. By interval of time, we mean how many times the event is occurring, say in 10 minutes, in 1 hour, in 4 seconds, in 3 years. So there must be the time factor or space. Here by space we mean dimension. Can be area, volume, distance. So here also, number of times the event is occurring, say in 10 meters square of material, in 2 kilometers, in 5 pages, in 15 milliliter of water. So there must be either the time factor or the factor of space. And it is to be noted that for a Poisson variable, the number of occurrences is infinite. Apart from being discrete, it is also infinite. That is, the event can occur an infinite number of times in a particular interval or space. So small x takes value 0, 1, 2, 3, 4 up to infinity. Now let's see the conditions for a Poisson distribution. So there are 4 conditions for x to be modeled by a Poisson distribution. First of all, the events occur independently. That is, the event does not depend on other events, or the other events cannot affect its occurrences. Second condition, the events occur singly. That is, 2 events cannot occur exactly at the same time. Third condition, the events occur randomly. That is, by chance. That is, the event has not been organized or planned. And the fourth condition is that the events occur at a constant average rate. Now we have some examples which could be modeled by a Poisson distribution. First one, the number of accidents at a particular junction per month. So here the event is accident. We are considering the number of accidents that can occur at a particular junction per month. So this is occurrences of an event, and this per month. This is a time interval. Second example, the number of phone calls received in 1 hour. So this is the number of occurrences, number of phone calls received in 1 hour. Again, we have the time interval 1 hour. And the third one, the number of typing errors. So number of occurrences in 10 pages. Now we have the factor space in 10 pages. Now for the notation, if X is a Poisson distribution, we write it as X follow PO. PO stands for Poisson, lambda. So lambda is the parameter for the Poisson distribution, and it represents the mean. Because earlier we said that the Poisson, the event occur at a constant average rate. So lambda is the average or the mean. Lambda is the constant average rate. Again, lambda is the mean. And also X takes value 0, 1, 2, 3 up to infinity. This is very important. And finally, we have the probability distribution function for the Poisson distribution. So the probability distribution function is some type of formula which enable us to calculate probabilities. So if X is a Poisson variable with parameter lambda, that is mean is lambda, then the probability of X occurrences, that is the event occur X time of a certain event in a given interval of time or space, is given by. So this is the PDF. Probability capital X is equal to small x. So here we know that X will take values, can take values 0, 1, 2, 3 up to infinity. The PDF is equal to e power minus lambda, lambda power x over x factorial. So if we are calculating probability X is equal to 2, that is a number of times the event occur is 2, small x takes value 2, then we must know the parameter lambda, the value of the parameter lambda, and then we replace x by 2. So it will become e power minus lambda, lambda power 2 over 2 factorial. So in the next lesson, I will show you how to use a PDF to calculate probabilities. Till then, thank you.